Hey guys, so in this video I just wanted to share an interesting electrostatics problem that I got. This deals with electrostatic potential and capacitance, and this is basically problem number 2.5 from the NCERT textbook. So in case you wanted to check it out, you can right now. But anyways, let's try to figure out what this problem is telling us. So we have to deal with a rather as it's just said, a parallel plate capacitor. So let me get a highlighter. Parallel plate capacitor with air between the plates has capacitance of 8 picofarads or PFs. I'm not sure if that's the actual unit, but they've given the conversion here as well, which will aid in our essentially our problem. What will be the capacitance if the distance between the plates is reduced by half and the space between them is filled with a new substance of dielectric constant 6. Okay, so first of all, let's sketch this diagram out in order to be able to answer this, right? So let's say you have a parallel plate capacitor like this, this is the first case. So case 1, you have a parallel plate capacitor like this, and we're suggesting that the capacitance C1 is equal to, let's just call it C1. Actually, let me take a different color. C1 is equal to 8 picofarads, which is the same thing to say as 8 into 10 to the power of minus 12 farads. Then now we have to take another case. So case 2, where the distance between the two plates has been increased. So that's point number 1. So it's doubled. So the distance between them is 2x, rather 2x, and the capacitance we have to find out in this case. So let's take the C2 is equal to what? Let's just take it as x, to make things simpler. And they're saying that it is filled with a dielectric constant. So this means to say that the space in between has been filled completely by a constant k equals 6. Alright, so first of all, we need to understand the main formulas that go into answering this question. Alright, so let's note down the formulas required, because this will easily help us. Formulas required. Number 1, let me note it down in this color. Hold up a second. Let me just choose. Okay, this is best, I think. Number 1 is we need the formula for total capacitance, or rather the capacitance between two parallel plate capacitors, and that will be equal to epsilon naught d by, or rather epsilon naught 0a by d. And this is assuming, of course, let's just say assuming the space as vacuum. All right, so this is assuming that the space is vacuum, which is only applicable for case 1. The second formula that we'll be needing is epsilon by epsilon naught is equal to k. This is the dielectric constant, which is k, and epsilon is, rather epsilon naught is the permittivity of free space. Rather, it's basically this part that you can see over here, and epsilon is what we will get when we find out the new mediums, well, the new mediums require properties. Anyway, let's start solving this question. Alright, so first of all, let me choose a different color. Alright, so we have to compare C1, comparing C1 to C2 will render us the answer. All right. So we know the formula is C equal to epsilon naught A by D. And since the only thing that will remain the same here is distance, in the sense that D will remain the same. Of course, in the second case, it would become C equals epsilon. Instead of epsilon naught, you would have 6 because of the dielectric constant that has been provided to us in the question. So yeah, it would essentially hold a value of 6, and A, which is the area of the plates. These two will get cancelled obviously, and here we would have D by 2, right? But this will just eventually render us C. Let me just name this C1 and C2. C2 equals 6 into A into 2 by D. Now let's represent these two formulas, which is here, in terms of T, right? Because now we will get, right, D equals epsilon naught A divided by C1, and D equals epsilon naught, or rather in this case 6, 2 into 6 into A by C2. Now here we don't know C2, we assumed it to be X. So now this would further become, and since these both are D, we'll essentially have to equate this to this because I've equated them in terms of D. So we would essentially get epsilon at A by C1 equals 12A by C2, right? And here the A's will cancel. Let me take a different color in order to represent that. So A's will cancel, right? And C2 is X. So finally what we will end up getting is epsilon naught by C1 equals 12 by X. We know the value of epsilon naught, we know the value of C1, we know the upper value over here, which is 12. So all we need to do right now is essentially X equals this would be equal to 12 into C1 divided by, wait, hold on. Yeah, divided by epsilon naught. So actually, I think I made a mistake. Hold on. Yeah, I made a mistake. Okay. So this is right. So C2 isn't exactly equal to anything like this. So let me just clear this completely. My bad. All right. So we assume the dielectric constant. So I messed up in the dielectric constant area. So we know that K equals epsilon by epsilon naught. So we know 6 equals epsilon by epsilon naught. Then we know the value of epsilon naught. So what we need to find out is how to represent the epsilon naught here as in this case we would be able to equate it as 6 epsilon naught is equal to epsilon, and this would be the permittivity of the medium which we have here. All right, so now actually speaking this should be equal to epsilon naught, right? Because obviously it makes sense. Now we finally get the value which is epsilon naught, again A by D equals 12 epsilon naught A by D, rather it will be, my bad, I'm making mistakes, this is my bad. First time's not the charm, I guess. So this would be C1 and this would be 12 epsilon naught into A divided by X. Yes. So obviously these will cancel each other and we'll end up getting 12C1 equals X. So we need to find out what is 12C1, and we know from before over here that C1 is basically equal to 8 picofarads. So this would just give us 12 into 8 into 10 to the power of minus 12 farads, which is equal to x. This would be 96 into 10 to the power of minus 12 farads equal to x. We can just represent this as 96 picofarads. And this is our answer. So yeah, pretty logical question, but I thought you guys might enjoy it. So yeah, thanks for watching.